Guys, this is going to be the solutions video for the sinusoidal function assessment. So you're doing it because you need to reassess. So when you're done and hopefully you have a better understanding of the problems, you're going to be doing the remediation problems, and then we can get you that reassessment going forward. All right, so let's take a look at this first equation. We have a cosine equation. The first thing I want to put on my graph is the midline, and that's indicated by this -3 right there. So at -3, I'm going to put in my midline. Now, because it's cosine, I know I have to start at my maximum or my minimum. And that is indicated by this negative sign out front, and that is going to be reflected. So I'm going to start at my minimum. So that minimum is going to be determined by the altitude. So if -3 is my midline, my amplitude is 2, then -5 is going to be my minimum, and -1 is going to be my maximum, as they are both 2 away from the midline. So I need to take into account this horizontal shift. I'm going to be going left to pi/4. And I'm going to be starting at my minimum. So at -5 pi/4, I'm going to have my first point. So the last thing I need to consider is this 4 out front here. And that is my frequency. So we can look at that two ways. We can say there has to be 4 cosine curves between a distance of 2 pi, or from -pi/4 to 7 pi/4. There got to be 4 cosine curves in there. Or I can do 2 pi divided by 4, which is pi/2. And that is the distance of 1 pi curve, or 1 cosine curve, sorry. So I know -pi/4 to +pi/4 is a distance of pi/2. So the curve is going to end there. So the distance between the red and the blue points currently is going to be 1 period. So now I have the key points that will help me. Halfway between there is going to be my maximum, which is going to be -1. Halfway between -pi/4 and 0 is going to be where it crosses the midline, so at -pi/8. And on the other side, between 0 and pi/4, it's going to be crossing at pi/8. So that is one cosine curve based on this equation. I want to complete this over the interval of -2 pi to 2 pi. So I'm going to continue this pattern. So 5 pi/8. I'm at the midline, pi/2, and my maximum. So now I have a positive cosine curve in there. And I'm looking and I see that there is a distance of pi/2 between every minimum and every maximum. So I'm going to put those points in there. In both directions. So I have all my minimums and all my maximums in there. And I know halfway between there is where it's going to cross the midline. So now I have all my points. I can create my curve. And that would be our completed graph for the given equation. Let's check out number 2. So this time I'm given the graph and I have to write the equation. So my key features that I need to figure out are my midline, my amplitude, my period, because that'll help find my frequency, and then if it's been reflected or not. So there's a lot of different answers on this one, but we'll start off with the most basic and go from there. So I know cosine and sine both start on the y-axis. This eliminates any kind of shift. So if I look at where it crosses the y-axis at 0, 2, I notice that starting on the midline, the midline is 2. So my amplitude, my maximum point is 6, minimum point is -2, so my amplitude must be 4. One full curve goes from 0 to pi, so that's got to be my period. So my frequency, 2 pi divided by pi, is just going to be 2. And because the sine curve starts down instead of up, it is reflected, which means there will be a negative sign out front. So now I have enough to write an equation. Negative, the amplitude, 4. I'm looking at a sine curve with a frequency of 2 times x. I have no horizontal shift. And my midline is at +2. If I wanted to look at the positive sine curve, again, I'll put my midline in here. I have a positive sine curve that starts here going up or starts here going up. So the only thing that would change there is now it's not reflected, but I have a shift. If I start here, it's negative pi over 2. If I start here, it's positive pi over 2. It doesn't matter, but the pi over 2 is my shift and my midline. And lastly, if you are doing a cosine curve, let's say you're doing this cosine curve right here, its maximum starting height is at negative pi over 4, so I have a horizontal shift. It's not reflected. So I'm taking into account the horizontal shift to the left of pi over 4. And that is another solution. So any of those three equations would work out as a correct solution. Let's go and take a look at the analyze competency. So here we're breaking down the parts of the equation. So looking at this first equation, the very first number is my amplitude, so that would be a 4. The frequency is the number outside the parentheses before x, so that would be 1/2. My period is 2 pi divided by the frequency. So 2 pi divided by 1/2 is going to be 4 pi. The horizontal shift is inside the parentheses with the x. So there's a horizontal shift of 5. It's positive 5 in the equation. So it is 5 to the right. Remember, our standard equation is x minus h, so the h value is positive. My vertical shift is 3. It's positive, so it's going up. There are no negative signs in front of the 4 or the x, so there is no reflections. On to the second one. My amplitude, always positive, so the amplitude is 8. My frequency, again, outside the parentheses before the x, is 5 pi. My period is 2 pi divided by the frequency, so 2 pi divided by 5 pi. The pi's are going to cancel out. I'll have 2/5. My horizontal shift is inside the parentheses, so that is 12. And it is negative 12 because x minus a negative make it positive inside the parentheses. So it is 12 to the left. My vertical shift is at 34 outside the parentheses. It's negative, so it's going down. And in this case, I do have a negative before the 8. So yes, there will be a reflection over the y-axis. So that's each part of the equations broken down into their key features. And the last competency is solving.